To synthesize polyanhydride nanoparticles, we begin by weighing the necessary polymer, typically 25 to 100 milligrams, into a glass vial.
In addition, the payload that will be encapsulated is added to the glass vial. In this example, we are encapsulating a fluorescent dye.
Next, methylene chloride is added to dissolve the polymer at a concentration of 20 milligrams per milliliter.
To ensure the polymer is fully dissolved and that the payload is evenly dispersed, the solution is sonicated with a probe sonicator for 30 seconds.
Next, we measure the required amount of pentane, the non-solvent, into a Nalgene beaker. We use enough pentane to achieve a 1 to 250 ratio of methylene chloride to pentane.
Due to the low glass transition temperature of the polyanhydrides, we add a stir bar to the Nalgene beaker and place it in a liquid nitrogen bath. The temperature is monitored until the pentane reaches negative 20 degrees Celsius.
Once the appropriate temperature is reached, the nanoparticles are precipitated by pouring the methylene chloride solution into the beaker of chilled pentane.
The precipitated nanoparticles are then collected on a number 50 Wattman filter paper via vacuum filtration.
Once dry, scrape the nanoparticles from the filter paper. We typically recover 50 to 80% of the original batch size. Place the nanoparticles in a microcentrifuge tube for storage. The nanoparticles should be stored dry with desiccant at negative 20 degrees Celsius or below.
Before use, the nanoparticle morphology and size are verified with scanning electron microscopy.
To prepare the nanoparticles for animal immunization, add sterile saline to the nanoparticles at the chosen concentration. Sonicate the nanoparticles on ice to disperse any aggregates.
Occasionally, the nanoparticles may need to be vortexed to maintain suspension.
Load the nanoparticle solution into a 1 milliliter syringe. Place a needle on the syringe and remove any air bubbles before use.